Hey everyone, I'm back. It's been a while since I've made a video, and I'm getting ready to start a new project that I wanted to share with everyone. But before I do, I kind of want to do a little closeout on Ralph here. Ralph is my in-move robot that I built, basically functioning and has some programming. But my Parkinson's makes it very difficult for me to work with Ralph anymore. So Ralph has now got a new home. He'll become a member at the Kids Robotic Academy here in Houston, Texas. So he's going to a good home, and he'll be much loved there, I'm sure. So let me now introduce our my next project. This is a SpotMicro dog, and this is the project that I've elected to start. It's small enough that I can manage it. I can do it all seated and at my desk. So it's going to be a great replacement for Ralph. I've started it already and I'm enjoying it very much. I think you would too. So let me share with you what I'm doing with him. Oh, by the way, my wife has named him Charlie. Okay, so this is Charlie, or what he'll look like. When I was building Ralph, you heard me many times refer you to Cyber One and to his web pages. Well, once again, I'm going to refer you there. He's done an excellent job with all the videos and the nuts and the bolts of how to build a SpotMicro. So I'm not going to try to steal his thunder. He deserves credit for all the hard work he's put in there. So I'm just going to direct you to his site and advise you to look at that, augment it with my site. You know, I'm basically I'm going to just share with you my little tidbits, my perspective, maybe from a little bit different than his. But he's the one that's going to give you the nuts and the bolts. So enjoy it. Here he is, Cyber One, and he's got 21 videos. Let me get down here smaller and out of the way. On his site, he's got 21 videos already up about how to build a SpotMicro. So go there. I would recommend that you watch every video before you start building. The first 4, 5 are critical for the hardware. Then he'll start talking about how to use my robot lab and in Python programming and everything on how to run the dog. So you'll learn a lot there. He's sharing all his code. He's doing a great community service with all that. To go along with that, I want to point out that he does in parts 1 and 2, he shows you how to build the legs. But down in 13, he shows you a modification to the leg. So you want to make sure you look at 1 and 2 and then look at 13 to see the modification. You can save yourself some print time, a little build time, a little material if you'll do that. Then he jumps way down into the video 21, which actually came out after I had already started building my legs, where he's changed the servos again. This is a third update on the servos, and it's a meaningful one. So make sure you go 1, 2, 13, and 21 at least before you start the build. The others might be better served later, but at least browse them. Open them up and browse through them a little bit so you can get a flavor for how he's doing this, where he's headed, what the project's going to entail. So I'm going to open up a little bit here for you and show you a little bit on this site as you can see here, he's listing all the STL files he used during this video so that you know what to get. He's kind of listing hardware that you'll need, and he's giving you links to many of his other resources. So I'm not going to stop and read them all to you. You can go to this site here and find those for yourself. But I will just drop over to his other sites quickly to mention them. He's got a lot of information on these sites, guys. So on his GitHub site, if you go to the SpotMicro, I will put a link to this in my comments so you can get there quicker. He does come in here and he gives you a lot of documentation. Let's open up the docs here. You can see he's going to go up and down. He even gives you a parts list. And here's the parts list as you'll find it on the site. It's a little dated. He still has a reference there to the first servos. And like I've said, he's updated servos two times since then. So get the list, watch the videos to see the changes that he's made. He even gives you references where you can go get some of this stuff, which is very helpful. So we can get in here and see some docs. And we can go into Spot itself. And here's his code. Here's all his Pi files that he's written. So you can get them, download them, study them, begin to learn how to work with it, modify that code to work with your particular model. All of us like to do our own little tweaking and customization. But you can start with a good basic code set here. Very good work. Now, for ongoing help while you're doing all this, go to Discord. He has a channel in Discord where he talks about SpotMicro, and he updates and answers questions. He's answered a couple for me on here. It's good community service. Get in here, find out what others are doing, see what problems you know are there, and how to avoid them when you're doing your build. So you might call that a commercial. I don't. I call it an attaboy. He's done a lot of good work. Use this site. Augment it with mine. My still pictures will give you a different perspective. Maybe add something from a different angle than when he does it. But believe me, he gets down to the nuts and the bolts for you. Now, let's take a look. We'll move on here to what I have to share with you. The first thing I'll say is that when I built this, I learned from Ralph that the infill is important for strength. And there was times when I broke parts on Ralph and I had to go back and remake them. Well, for Charlie here, the little SpotMicro, I elected to do 100% infill on all my parts. I just said strength is important. It's not going to be that much more material. I've got the time. I'll wait for the prints. So that's what I did. I made all my parts 100% infill for the strength. Then when I started making the leg, this is the wrist joint. And I discovered these gaps that I pointed out here with the arrows. They weren't fitting together well. And I thought, is this gap indicating that the part is the wrong size because it matched so closely to this gap not being able to close? So I went to Discord and I posted and I asked, hey, what's going on? What's the issue here? And Cyber1, or Ray, his real name, said, hey, this gap here on the wrist is on all his parts. It's normal. It's supposed to be there. So that the real problem seems to be this joint down here, not making up right. He suggested recalibration, so I did. I recalibrated everything, did my little cube, did the extruder feed test and all that, and everything looked good, which I expected it would. So then I took a closer look, because after remaking these parts, I had the same exact problem. It looked just like this, even with the second print. So I took a closer look, and I discovered that I had a lot of rubbing action right in through here on both sides. So I got out a file, and I filed here, and I filed here, and I filed up in here, and I filed up in here, and I just widened that a little bit, and that gap closed. Well, it got very narrow, and I was able to pinch it shut, right, and put the screw in. So I had a nice tight fit. Another thing that I discovered was that though it looked pretty, the bearing that goes in on this side wasn't quite seated in deep enough. So, I cleaned that hole a little bit better, and that bearing slid in that 32nd of an inch or whatever it was, slid in a little bit deeper. That gave me a little bit more room. So look for that kind of stuff. That's the only fit problem I had building the dog. Everything else fit together nicely. My hole sizes, I ran my drill bits through them, but they just fell through and everything looked good. So pay attention to that. If you have this problem, it may be that you need to do a little filing. Now here, what I elected to do while I was waiting for hardware parts to come in, I elected to do my printing in bulk. So as I printed this stuff, I was ready for assembly. And I wanted to see how all the printed parts were going to fit before I did much with the hardware. So I pre-assembled things just to test fit. And I thought that was a good idea. And again, this is what showed me that everything went in place smooth. No issues, no fit problems. Everything just went together. So you might consider doing this. Another thing that it helped me to see a little clearer was really how the final assembly of the legs, the shoulder area, came together. I watched his videos and I learned from them, and they gave me the confidence to move forward. But I wasn't really confident about how these shoulder parts went on. So by laying these out like this, it really cleared it up for me. And I lost all that doubt. I knew what I was going to do now. So he talks about parts being the same but mirrored. And I wanted to show you with the parts laying like this how that mirror works. It might help you to see it a little bit better. So let's start with these plates up here. You can see that this is the 6-spur gear that goes on the end of the servo. Well, there's one on the front of the robot. You're looking at the back of the robot here. So the front of the robot, you're seeing the back of that plate. So you can see it's mirrored. That gear, that black gear is on the outside in the front and on the outside in the back. So you have a mirror situation. That means the bushing holes are on the inside and on the inside. Pardon me. So when you go to put that shoulder in, you have to reverse those servos. And I laid them out here. Hopefully you can see that. You can see the little pin here, right there. That's the pin that goes into the bushing right here. And you can see that the pin has to be on the opposite side for the rear because it's going on the inside as well. Another secret to look for here is this reinforcement arm. This is talked about in video 13. This is one of those modifications. Right? So you have to print a couple of different parts there. So watch for that modification. This reinforcement arm goes on top. You'll see it. I'll show it here in a video shortly. But there's a hole here and a hole on the side here that you can't see. So that mounts right here. You can see that screw, and maybe you can see it better down on this one. The screw down here, and there's the hole right there that goes in there, right? And then this hole matches with this hole right here. So those two holes line up. Here you can see you got the top hole, but the other hole is hidden on the back side. Again, that's that mirroring action. So you can watch for that. Just lay those parts out and you'll see it. It becomes very clear. I also followed his advice. I did do a little hard work, guys. You know, it just made sense to do it as I was doing this assembly. These are the voltage regulators. One will be set for 5 volts, for 5.1 volts for the Raspberry Pi. And the other one, he was eliminating on his because he upgraded servos. But I'm going to leave it in based on video 21. Again, study all his videos first. But in video 21, he talks about these 35K replacing these servos that I'm using. They're 7.2 volt servos, but he says they burn out. They have a tendency to burn out when you run them at 7 volts continuously. So he thought they would work real good at a 6 volt system. He moved to a new servo that is 8 volt. So the 7 volt battery is not an issue for him anymore. But since I've got these and I've got this power regulator, I'm going to listen to him. I'm going to adjust that for 6 volts and power my servos at 6 volts, maybe to prevent that burnout. In his video, he shows you how to mount all this. Great idea. He deserves full credit for coming up with that solution. Very workable, easy to do. Take a look at it, guys. Here's the side view of what you're looking at. Right, this is the right-hand side that you're looking at. So you can see that the wrist is fully bent upward, and you know the legs are sitting on the wrist. You can see the pin on the outside. That's where the bushing for these plates goes in. You'll see it in another video better in a minute. And then this plate gets mounted onto this servo. And here you can see the pins pointed in, both of them pointed in. That's that mirror effect again that he talks about. You have to get your left and right sides put together in the right order. I was a little confused on whether this plate mounted vertical with this or had an angle on it. He was saying vertical, used a ruler, but I don't know, it just wasn't coming across to me, so this helped me to solve that. You'll see again in a minute. Now, this video is a little bit out of focus. The only person I know with a worse tremor than me is my wife. she's trying to hold that leg up while I'm trying to hold a camera in my hand. So between the two of us, we didn't get a perfect focus on this. But it will help you to see how this is going to fit together. Okay, so this is the leg here. And this is the side plate that I tell you goes on. And you can see the top hole here and the side hole here for the reinforcement bar that's going to go run across the top of this when I put it on. Now, what you can't see is the back side, right? Or I should say the front of the servo. No, the back of that servo, where that little white pin is. That white pin goes in that bushing right there. That allows this spline of the servo to pass through the hole here and let you put that 6-pin gear on there to hold everything in place. And you can see that this is vertical and in alignment with this one. So both of them end up being vertical to each other. Now, I will tell you again in video 21 that he says he's discovering that instead of being aligned 90 degrees like this, it might be better to use a 45-degree angle between these servos. I've got to study that some more to see what he's talking about, but I mention it here because I want you to watch all his videos before you start, because as he progresses, some things change. And it's helpful to see them before you get committed to an earlier version. So I'll study that, but right now mine are at the 90-degree mark. And I'll cover that a little bit more in a second here. This is just another angle of that same shot. Here you can see the pin that goes in the bushing, and here you can see the servo shaft that'll pass through the hole over here. And here's the screw, and then there's the hole on the side for the arm that's going to go across here, the reinforcement arm that he talks about in video 13. There's a leg fully assembled. This, see the R? That's a right leg. This happens to be the right rear leg. And I marked them, I put R on them down on the bottom of the foot where the rubber will go over and hide that when it's all done so that R won't be visible. But this is the right rear leg fully assembled. And you can see here's the reinforcement arm that comes around and has an additional bushing, pin in the bushing here, one screw here, and the other screw is on the bottom. It's laying on it right now. Here's the pin that goes into the bushing in the shoulder, and of course the servo spline on this end. So that leg is fully assembled and ready to go in place. These are the two assemblies that you have to pre-build so you can mount them on the ends of the body. And I laid this out like this again because I think it really clears up some of that mirror image that you hear talked about. This is the front set of legs. Right? The body sits in here between these, right? And so these two ears are facing the head on the outside of the body. So when you pick that part up, you pick it up like this, and it bolts into the body. Down here, this is the back set of legs. And you can see the mirror now. This piece is flipped 180 degrees, and these gears are now on the bottom side. And the white pins with the bearings are now up and facing you. That's because you'll pick this piece up and flip it this way to attach it to the body, so that those black gears are one set faces the tail and one face will face toward the head. I hope that lets you see the mirror image that we keep talking about a little bit better. Then all four legs then are facing towards the head when you pick that up and put them in place. Here you can see this is the tail of the dog. And this is what I'm talking about, those black gears. You pick that up and you put it in place, right? You screw this 1, 2, 3, 4 bolts in, and that set of legs goes into place. on this one, I did a quick and dirty little assembly, and here you can see I forgot to put the bearings in on this set of legs. Of course, it's only temporary, right? Just test fitting stuff. But there are bearings in this side. There you can see I got the bearings in. On the back side, you can see that the bearings are in place there on the back set. This front set, this picture helps just show it for clarity. What I'm doing is I'm mounting my nano right here in this little nano holder on the just behind the head. And again, that came later in his earlier videos when he's doing the hardware. He shows mounting that nano on the main Raspberry Pi next to the Raspberry Pi board. He later moved it too, and that's because he added more servo control cards. So again, another reason to watch and look through them all before you start building, so you can say, aha, this is what I want to do. Here you can see the legs facing forward. Everything's looking pretty nifty there. This is a right rear leg seen from a different angle. I just elected to take some pictures and show different angles. Hopefully, as you see it from different perspectives, you get kind of that 3D idea, how it's all going to fit together. Here's the front leg, right front leg. Here's the front view with the head on. You can look in there, you can see those black gears back in there. And of course, I haven't gone to the detail of mounting that hardware in there yet. That's my next step. Here he is with all the plates in place, everything being test fitted, so you get a good idea of what he looks like sitting on his stand. Right. Everything, like I said, everything went together well. I would tell you to watch this plate, the top and bottom plate, when you get ready to go. This is called a non-meg plate. Okay, and there's two sets of plates in there. I guess if you're going to use the Arduino Mega as the main board, you use a different set of covers. And if you're using a Raspberry Pi, you use a different set of covers. And hopefully I can show you why here in a minute. Just another angle. Rear view. Another rear view angle. Here's this hole right here. I wanted to point this out. Ray mentions this. There's the SD card. There'll be times when you may want to take that SD card in and out. and without having to do a full disassembly, he discovered if you put a hole here that you can get that SD card in and out without having to do a full disassembly. Neat idea. Looks like it'll save some work, so I want to give him credit for that. I wanted you to see where it's at. He gives you a left side and a right side for that without that hole in it, and then you put your own hole in it. Of course, that hole went in, pardon me, fairly easy. Wasn't anything real difficult to figure out. So those kind of wrap up where I'm at right now. Let you see what's been happening. Oh, I said I wanted to cover one item with you that I hadn't covered yet. And that's a little bit about servo angles. Let me refer to my notes over here so that I get these right. Okay. This is the right side of the robot, and this is the left side. Whoops, backwards. This is the back of the robot. This is the front of the robot. So looking at him from the front, let's turn him around. There we go. There's the face of the robot. Now it will make more sense. So this is the left side of the robot, and this is his right side as you're looking straight at him. So on the left side of the robot, this servo gets mounted at 0 degrees. You want to set this servo and this servo to 0 degrees and then mount him just as you see him right here, right, with that arm fully folded up. Then when you go to 180 degrees, that leg will swing down and back. 0 brings it back up. Now, on the right-hand side, it's mirrored. So that means you got to change the servo setting. So on the right-hand side, you want to set this servo to 180 and mount him with the leg fully up like that. And then when you go towards 0, that leg will swing down, and 180 will swing it back up. Now, this servo and this servo, set them at midpoint, at the 90-degree mark. Now, I'll also point out some discussion we had when we were talking about the My Robot Lab software. If you use My Robot Lab servo services to drive your robot, you're going to see them, they're marked from 0 to 180 degrees, with a 90-degree being the center point. Well, my servos moved from 0 to 270. It was also commented that the new finger servos for the new hand for the for the InMove robot are 0 to 300. So when you're using that servo control, it's permanently 0 to 180, but it gives you full range no matter what the servo is. So my 0 to 270 is represented on the servo as 0 to 180. That 90-degree mark is the center point. Even though it says 90, for my servos, it's actually 135. So don't get too confused by that mid-range setting and 0 and 180. Just use them as minimum and maximum and midpoint, and you'll be all right. So they're looking at what they maybe can do to make that clearer on their servo services. They may change it. They may elect not to. But this servo is set to midpoint. This servo is set to midpoint. This servo is set to minimum, which is 0. And this is set to maximum. In my case, 270 180, depending on what servo you use. So I just wanted to point those out. That this being at midpoint, right, you can see that gives you half your movement to lift the leg and half your movement to pull that leg back. Also on the shoulder, it gives you half the movement to lift that leg up and half the movement to fold that leg under his belly. And you probably never will fold him that far, but you need that motion to help for stability with the robot. So I hope all that helps clarify things, let you see the robot in different stages. This is just the plastic parts. I'm now getting ready to do his guts. I do have the Raspberry Pi. I'm starting on the hardware and the software install. I'll do some videos on that. Ray has already done those. They're real good. I'm just going to touch on them again. His is a good lead to follow. Okay, I hope this was helpful. I am enjoying this project a lot. It's been good for me. I hope you can enjoy it as well. That said, I'll see y'all later. Bye-bye.